Okay, good morning class. So today we're looking at Euclidean geometry, the circle geometry, and at this point we are busy with non-numerical examples. So what is numerical? What is numerical? Numbers, not so. So non-numerical is not numbers. Now you have writers or examples that has no numbers in it. It has variables only. Okay. So, looking at example 1. Example 1 is on page. Example 1 is on page 317. And the exercise on page 319. Okay. Okay, so heading is non-numerical example. Okay. Doesn't it make this a bit smaller? Example 1. We are told RP is the diameter of the circle. So if RP is the diameter of the circle, what can we determine at this point? What can be concluded? Q is 90. What else do we know? T2 is 90. Okay? Then we are told that chord PT is produced. PT is meant to extend its own length to S. Second S or Q cuts the circle at R and Q. TR and PQ are drawn. Right. With that in mind, first question. We need to prove that R ST is congruent to triangle RPT. There are 4 cases for congruency. What are the cases? Side, 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 angled side, angled side, RHS. Okay? So one of those cases we might have to prove. So in the 2 triangles, what can we say? Let's take this away so that I don't get confused. That are the 2 triangles for those of you who can't see. Those are the 2 triangles. So what do we know? We know that T1 is equal to T2 is equal to 90. Why? Angles on a straight line. Did we know that ST is equal to TR? Why? TP, sir. Why? Given. And TR is common side. So what case of congruency is that? Side, angle, side. When do I use RHS? Do I use the hypotenuse? Did I use the hypotenuse here? No. So I'm not going to use RHS. You guys understand? Let's take this off here. So we say T2 is equal to 90. We have to start there first. Where do we actually start prior to this? We say in triangle RST and triangle RPT. Do I have to write this here? No. When we prove similarity and congruency, we don't have to write it. You won't use a mark if you leave it out. Okay? So that is equal to 90. Why? Why is this 90? Angle in semicircle. Did we say that? T1 is also 90. Why? Angles on the straight line. Then we say, secondly, we say that ST is equal to TP. Why? Given. Then TR is a common side. It's either common side or common angle. Don't just write common. Okay. Is that enough to conclude congruency? So therefore triangle RST is congruent with triangle RP2. Why? Side angles. So with that said, we have now proven that these angles are congruent. So what can be concluded now? We know that angle S is equal to angle P1. We know that angle R1 is equal to angle R2. We know that RS is equal to R2. Okay. Will you guys understand? Something like this worth 4 marks. Okay. So it's worth you while going through it. Okay. Let's look at B. In question B, we are told I'm just going to keep the fact that the two triangles are congruent just there. As you can see, we're running out of space here. I also want to keep the diagramming focus. So let's look at B. B says if P1 is X, write the following in terms of X. So in terms of X, what would angle S be? Angle S should be 1. Triangle RST is congruent with triangle RP. Okay. You guys got it? It was B1. Let's look at B2. Angle R3. How do you calculate R3? Yes?
Isn't R1 and R2 equal?
Yes?
Can't you just show them?
Good, nice. So R1 and R2, angle in triangle. Then those two are equal. Or again, angle in triangle. Then the angles on a straight line. Yes, absolutely. That's the easier way. Exterior angle, there we go. Can you see that, people? So R3 is equal to X plus X. Why? Exterior angle of triangle. So R3 is equal to 2X. Exterior angle of triangle. And the exterior angle of triangle is RP. Number 3, P2. I'm going to calculate P2. P2. What do I need? Q. If I got Q, I can go with sum in triangles. Not so. But angle Q is equal to what? 90. The angle Q is 90. Why? Angle in semicircle. 90. So I will calculate P2. Angle P2 plus 90 plus 2x is equal to 180. Why? Sum of triangles. And this triangle PRQ. Do I have to stay in the spot? No. So P2 is equal to 180 minus 90 is 90 minus, yes, angles in cyclic quad. If you're going to go with angles in cyclic quad, then you must first work out R2. But if you had gone that route that you would have to work out sum of triangles, then you would have picked up R2. Then you can say yes, that that's going to be 90 minus x plus 2x plus x plus P2 is equal to 180, opposite angles of cyclic quad. Then you would have also gotten P2 to be 90 minus 2x. Okay, anything else? No. Beautiful, no? Then again, all sounds is beautiful. Example 2. Here's a spicy. Spice up your life. Example 2. Example 2 is on page
18.
Sorry? The 18. Right, so here we are told, I'll probably move this over. So here we are told that TR is a tangent to the circle at R. TR is a tangent to the circle at R. People, if this is a tangent to the circle, what can be concluded? Sorry? R4 is equal to M2. Why? Tan core theorem. What else? R2, yes? Is equal to? Angle B if needed. She's saying R1 is equal to? R4, why? Okay. Just by knowing that's a tangent. Then we are told that diameter PQ, if PM is the diameter, what do we know? R3 is 90. Before going any further, what do we see? Straight line, yes. What else do you see? Okay, let's read on. Is produced to be the tangent at T. T is perpendicular to to TP. So what do we notice now? It's 90, no? So again the question, what do you notice with relation to those two? It's 90 and 90, it's the same. So what is this here? Cyclic quad. Why? Exterior angle is equal to the interior opposite. Did you see that? Did you see it? But you see it now. Okay. Then we are told that PR produced meets TS at S. MR is drawn. Prove that. First question out of the gate. Prove that TMRS is a cyclic quad. I can't believe it's so easy. I'm upset, no? It is so easy. But people, you guys understand? No? So let's go. So A. You are required to prove that's a cyclic quad. So where do we start? We need to know that R3 is 90 degrees. Why? Angle is semicircle. Now we say since, now we state the obvious, no? We say since R3 is equal to STP, which is equal to 90. Okay? Therefore, TMRS is a cyclic quad. Why? Because of the exterior angle equals the interior opposite angle. Don't say cyclic quad. No? Exterior angle is equal to the interior opposite. Okay. Then the next question says, prove that R1 is equal to S. R1, who is R1? R1 is equal to S. Here's R1 is equal to S. Okay. Remember people, this is a cyclic quad. Okay, don't forget that. Okay. So angle R1 is also equal to which angle? R1 is equal to T2. Why? R4 yes. Why? Vertically opposite. So R1 is equal to R4 vertically opposite. Or I could have said let R1 equal X. So it will be X here and X here. Not so. Then what? R4 is equal to which angle? S. Why? Oh, cyclic chord. Here's the chord. That is the exterior. Not that one. Can you see? One of the lengths must be extended. R4 is equal to which angle? Huh? M2 is. Why? M2 is. So R4, I'm going to show you now how to do it without your X. No? The holiday is over. So R4 is equal to M2. Why? Tan chord theorem. Now what? That's not the exterior angle of the cyclic chord now. So that is now S. So now we say M2 has to be equal to angle S. Why? Exterior angle of cyclic chord. But what is the question? You have to prove that R1 is equal to S. Now if R1 is equal to R4, R4 is equal to M2, M2 is equal to S, therefore R1 has to be equal to beautiful. No? Can't help but to fall in love with these sums, no? Alright. Well, example 3. Example 3. Example 3 is on page 18. A, B and C, D are two parallel chords. People, if these lines are parallel, what do we know? We know many things. Okay, but we will know that angle C3 is equal to B3. We also know that angle A is equal to the combination of C1 and C2 corresponding. And alternate and all of them, many things funny. Okay? Zara? You still among the living? Alright, so A, B and C, D are two parallel chords of the circle. Then we are told that AC and BD both produce, which means to say they extended to intersect at P. Can you see that? They meet at P. The tangent to the circle at B and C, the tangent to the circle at P. People, both are tangents. So if this is a tangent, what do we know? B1 is equal to angle C2. Can you see an exterior angle? Tan chord theorem. Can you see that? So that actually gets the same marking. Okay? That's a tangent. This is also a tangent here. So what can be said there? That the combination of B1 and 2 is equal to C2 and 3. Angles opposite equal sides. Tangent from common points. Okay? Yes? Both. The tangents to the circle at B and C intersect at Q. So both are tangents. We are then told that B and C are joined. Right, first question. Before I take everything away here, the first question says, they first want you to calculate You must show that angle C1 is equal to B3. So C1 is equal to C5, vertically opposite. C5 is equal to B3. Why? 10 cos theta. There we got that one already. Yeah? And so I'm going to move it over now and write it down, but because of the markings here, I don't want to move it yet. Okay? You look at the second one, B1. So just remember, that one, and that one was equal. No? B1 and B3. So B3 B1. B1 is the same as C3. We marked that already. No? Tan cos theta. And C3 is the same as B3. Why? We mentioned this also. Can you see that's the same marking? Alternate angles. So there's that as well. So what do we notice now? Cyclic quadrant. The bow tie. Why? Because those angles are equal. Can you see? It's so easy. Okay. You okay? Go see others, man. Leave the guys. Huh? WhatsApp them later. I feel cheated on. You're busy with other stuff. Right. But you guys see how easy is it? Right, so what we're going to do is we're going to move this over with all that information. It's on this tackle the sun quickly. Right, so let's go. So I'm going to introduce my x again to the story. Since Coke is not taking note of us. He says C1 is equal to B3. So what do I say? Let angle C1 equal x. So this is angle C1. Now what? We must prove that C1 is equal to B3. No? This is B3. C1 is equal to C5. So C5 is also equal to x. Why? Vertically opposite. Okay. And then C5 is equal to B3. So B3 is also x. Why? Tan cos theta. So therefore, C1 is equal to B3, which is equal to? So this is that one switch. B1 and B3. Right, since B3 is already marked x. Which other angle is x? C3. Why? Alternate angles. Not so. So let's go. I'm going to say that C3 is x. And we see this. Alternate angles with AB being parallel to C. And now B1 is equal to x. Why? Remember that's a tangent and there's your triangle. So that is, what is that, people? Which theorem am I using? Tan cos theorem. So B1 is equal to x. Tan cos theorem. Okay. And therefore, what do you notice now? B1 and B3 is marked x now. Therefore, B1 is equal to B3, which is equal to x. Let's look at C. C says prove that B, C, P, Q, the cyclic quad. There are three ways to prove cyclic quads. What are the three cases? Opposite angle cyclic quad supplementary. Exterior angle equal to interior opposite. And angles in the converse of angles in the same segment. Okay. So what do we notice here? Here, if there's many diagonals here, we always check for angles in the same segment, and there it's evident. Did you see that? So I don't have to prove anything. I can just go straight into the conclusion. I say, since what? C. What is this? C1 or C5? C1 is equal to B1, which is equal to X. Therefore, BQPC is a cyclic chord. Why? Because the converse of angles in the same segment, or I can say equal chords, no, equal angles subtended by the same chord. That was the converse of angles in the same segment. Okay. Sum like this is worth 2, 4, 6, 8, about 10 marks, something like this. Okay, this only if you want it. Okay. People, with that you should be able to do exercise 9.7. And 9.7 is on page 319. But we're going to break this up for the next couple of lessons. For tomorrow's lesson, I would like you guys to do, since there are 10 sums, I want you guys to do the first half, so the first 5 sums. Okay. If you can't manage 5, then 3 should be fine. I would probably only mark 3 tomorrow. Okay. Because of time. Okay, but every day we will have to do a bit so that we can conclude the geometry section. Okay. But also try and work ahead so that if maybe I have time to answer 4, I'll answer the number 4. Okay. The full lesson can be found in the description box below. Alright.